Okay. Just double checking. Oh, still going, and the microphone is on. Made that mistake before. Try not to make it again. Word up. Unit 6, Lesson 5, describing trends in scatter plots. Let's look for associations between variables. That's what it just says here. Question 1 says which one doesn't belong, or the warm-up. Which one doesn't belong? Remember, you can argue why each one doesn't belong. Do you think you could find an argument for why each one doesn't belong? I'll give you a minute or two to look at that. I think everyone's probably going, well, the last one doesn't belong because it didn't have a line. Yes, but why could the first one not belong? Why could the second one not belong? I guess it depends on, let's call this 1, call this 2, call that one 3. Maybe you say the first one doesn't belong because it is the only one that has an association in data. It's the only one that has an association in data. That is trending upwards. The rest all go down. Number 2, you could say doesn't belong. Why? What does number 2 have that the rest don't? Number 2 gets into the negatives. The rest do not get into the negatives. Number 3, what does number 3 have that the others don't? I wonder what you could argue. Curious to know what you're thinking. My only thinking is its data is a lot. It's got a lot more outliers. Probably there's some other things we could say too, but long story short, we've got some tendencies and trends in data there. This one is upward. This one's going down. This one's going down, but maybe not as steep as a rate. Although that number 3 and 4 look similar. But let's move on. 5.2. As I've been mentioning for the last several days, pretty soon, by that I mean right now, you're going to draw what you think is an average for all of the points in a scatter plot. It says your teacher's going to give you a piece of pasta. Don't really need the pasta. You do need a straight edge, and you can draw some light lines and erase them. The pieces of pasta kind of allow you to move a line around so that before you draw a line, but you can kind of do that with a ruler, especially if you had a clear ruler. But at the very least, whether or not you have a ruler or a piece of pasta, you can just draw some lines and erase it and redraw it. But long story short, we're going to try to make some models like we saw in our activity a couple days ago. Model is just a line that represents all the data to the best of your ability. It says here are 2 copies of the same scatter plot. Experiment with drawing lines to fit the data. Pick the line that you think best fits the data. So your line has to be straight, right? Because we do want a linear model, because then if it is linear, we can actually use it to find a slope and a y-intercept. And the slope and y-intercept gives us lots of information. Remember, slope usually gives us a rate of some sort. Something is happening per something. And the y-intercept lets us know where something is starting from. There's usually valuable information from that as well. So if I just drew a line like this, that's not going to cut it because it's not linear. It doesn't have a slope. So we do want as straight a line as possible. I wonder if I can cheat, which is something you can't. I wonder how easy it would be for me to try using my line function. If I were to try to draw a line, and actually it gives me 2, so I'm going to try, I can kind of go like that, like you would with a piece of pasta. You can't. I'm going to try drawing a line maybe like that. I'm going to try drawing another line. Maybe it shouldn't go through there. So you guys draw your line as you see fit. I wonder if that's a little better. I don't know. You can clearly see that my lines aren't identical, but they're kind of close. They're a little bit off, but that's the whole point of this activity is you try drawing a couple lines, and I'm not sure, maybe my second line's a little too low. Maybe it is, maybe it's not. I don't know. Point is you draw a couple lines and you see that's easier said than done, but we can draw an association between all this data. Number 2 says, here are 2 copies of another scatter plot. Experiment with drawing lines to fix this data. Pick the line you think is best. This is going to be pretty subjective. That means it's not going to be exact. There are computer programs that do this for you. But it's better that you know that how to do it manually before you agree with what a computer program might throw at you. So this, everyone might have some different lines, but some are going to be better than others. If I were to say, and in fact, when it says, I was just looking down there to see if there's a better way to explain it, but it says, in your own word, describe what makes a line fit data well. If you were to say, like, well, when I draw a line, I like half the dots to be on top of the line and half the dots to be below the line. And that means it fits the line well. Because you could argue that up there. You could say maybe half the dots are above, half the dots below. That might work. If I use that same reasoning, I could just say then, well, guess what? This line says half the dots are above, and half are below, even though that's not true because I didn't draw it very well. You can see that line of reasoning for number 3 when it says, in your own words, describe what makes a line fit a data set well. That's part of the reasoning, but that's not enough because cutting it in half isn't going to quite cut it. So let's try drawing a few. I don't know if something like that I'm just going to do by hand. Maybe that's a good association. Maybe it should be more like that. That's slightly different. So in your own, what makes a line fit the data set? Well, go ahead and write your own words down there. But I think we agree that the line should go in the average direction that all the dots are moving, right? Average is kind of subjective, meaning it's hard to find the average direction without using mathematical models. What else could you say? Dots should be both above and below the line. Might be something else we add. What else can we say? All the dots should be near the line as possible. Maybe that's another third thing we could say. I'll let you finish that, but I gave you a good 3 things to write down, and when you're done writing that down, then move on to 5.3. I should have mentioned this earlier, but if you haven't already, make sure you pause this when you need more time to think or work on something. And I should have looked at what time I started this video because I always forget if I'm running too short or too long. 5.3 says, good fit, bad fit. The scatter plots both show the year and price for the same 17 used cars. However, each scatter plot shows a different model for the relationship between year and price. So same dots, but you can notice they drew a different line. Look at diagram A. For how many cars does the model in diagram A make a good prediction of its price? For how many does it make a good prediction? So the model is the line, so we're focusing on the line. For how many cars does the model make a good prediction of its price? So if we look at this, that's pretty much on the line. That's a good prediction. That means the line is predicting the actual price. That's another one. You could kind of say this is pretty close. This is pretty close. This is pretty close. You could either say it's 2 or 5. 2 are kind of right on the line, but there are 3 others that are pretty close. So whatever you want to say for A, you could say it's 2, 3, 4, 5, right? For how many cars does the model in diagram A make a good prediction of its price? For how many cars does the model underestimate the price, right? So the model is that line again, right? So let me get rid of that. The model is that line right there. How many cars does the model underestimate the price? So is that asking for all the dots underneath the line or above the line? I have to read that again because I'm not 100% sure. For how many cars does the model underestimate the price? So these 1, 2, 3, 4, 5, 6, 7. There are 8 cars that the model underestimated the price. For how many cars does it overestimate the price? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. That just means if there are 17 cars, what's left? That means it overestimated for 9 cars. The model, if you look here, the price for this car, it says it should be here. For this car, it says it should be here. All of these, if we drew a line straight up to them, that's saying what it should be. But question C says, for how many cars... No, never mind. Forget that. We did that one. Question 2, look at diagram B. For how many cars does the model in diagram B make a good prediction of price? In my opinion, it looks like it's only that one. Is it exact, right? And kind of want to erase all that again so that I can kind of see. Kind of only one for A. For how many cars does the model underestimate the price? Well, it looks like there's just 1, 2, 3 that it underestimates the price. And that means there must be 14 if there's a total of 17 cars that it overestimates the price. Question 3 says, for how many cars does the prediction made by the model in diagram A differ by more than $3,000? For how many cars does the prediction made by A differ by more than $3,000? So we've got to look at all of these. Here is the price for this, and here's what it should be for 2007. Here's what the price is. First off, is that more than $3,000? The question is saying more than $3,000. Technically, that's like almost exactly $3,000. So it depends on if we want to include that one. But the model says a 2007 should cost $9,000. But this 2000 costs $12,000. So we'll count that as more than $3,000. This says 6, 7, 8. So this is $7,500. That's not more than $3,000. So we don't have to include that. The difference between those two costs This 2008 cost 9,000. The model says it should cost maybe 10 or 11,000. Who cares? It's not more than 3,000, so we're not going to count it. If you notice, we need the total distance of one of these blocks. So which other ones? This one has more than the distance of a block. That's 18 to 15 plus some. That's more than a $3,000 difference. So that one, that one, that one, and this one. The rest are less than a block. This one maybe, but it still looks like it's less, so we're not going to include that one. These all have a difference of more than $3,000 because remember, one block is 3,000. So the model is way off for some of those. So that's 1, 2, 3, 4. So down there when it says they differ by more than, there's 4 cars that differ by more than 3,000, meaning the model's not good for those 4. So what about diagram B? How many have more than 3,000? Well, I can see this right here is more than 3,000, so that's 1. That's 2. This is more than 3,000 away from the model. And I'm going straight up. I think I showed you earlier. If this is a 2007, I'm saying, well, the model says it should cost 12,000 and something, and this one only costs 7,500 or so. Let's see here. This one, that's more than 3,000. This one's more than 3,000. This one's more than 3,000. So there's 1, 2, 3, 4, 5, 6 so far. And this one, it's hard to tell. But we could say it's 6 or 7 for that last one. Which model does it better? So what about the diagram of Model B? We'd say 6 or 7. So with that being said, look at Model A has only like 4 or so. Model B has 6 or 7 models. So apparently, if you look, I'm going to erase all this again. There's 2 lines that represent the data. According, Model A seems to be like it is the better line. Model A is better than B. There's less outliers, so to speak, according to that model. So it says, which model does a better job? It doesn't even ask us to explain. I guess all we got to do is say, and I guess it's A. And then finally, guys, 5.4, practice fitting lines. Is this line a good fit for the data? Explain your reasoning. Number 2 says, draw a line that fits the data better. Well, so I guess that answers number 1. Is this line a good fit for the data? We should probably say no, because it says draw a better one. Go ahead and write in your own words. Why do you think that line is not a good fit for the data? Whatever words you want. And then draw a better line. What do you think would be a better line? Again, make sure it's straight. Oh, you could draw it on number 1. It's asking you to draw it down here, or for you it might just be to the right. So I'll leave it up to you wherever you draw it. And then number 3, is this line a good fit for the data? Explain it. Draw a line that fits better. It's kind of a good fit, but yeah, it's hard to say. Yeah, I can definitely see a better line being drawn. So for number 2, you can draw it. For number 3, you could say it kind of is, but not really. And then draw a better one. Again, it gives you another data plot that you could draw it on. But you could draw it on the same one so that you could kind of easily see the difference between the two. Hey guys, that's about it for that lesson. It's really just practicing what good models look like. So Unit 6, Lesson 5, practice problems are your homework tonight. I'll knock out a couple for you, and then you can finish the rest. It says draw a line that you think is a good fit for this data. For this data, the inputs are horizontal values. The outputs are the vertical values. That's weird. Usually, oh yeah, no, that's right. Sorry. Yeah, inputs down there. Use your line of fit to estimate what we'd expect the output value to be when the input is 10. So notice there's no dot on the 10, but if I were to try this, I would maybe say it's roughly straight, give or take. Now, it says use your line of fit to estimate if the inputs are the horizontal values. Horizontal means left and right. These are the inputs. And these are the outputs. I got inputs and outputs. Use your line of fit to estimate what you would expect the output to be when the input is 10. So when the input is 10, my line tells me the output should be 30. Roughly. Maybe your line's different. Maybe you said 32, or maybe your line's down here and you said 28. Output should be, I'll say 30-ish. Number 2 says, here's a scatter plot that shows the most popular videos in a 10-year span. It shows the dates, and then it shows the billions of views. I bet you Baby Shark is one of those, for crying out loud. How that gets a billion and some, that and Gangnam Style. You probably know the others better than I do, but I do know those two are ridiculously, well, Gangnam Style is kind of catchy. I'll give it that, but Baby Shark, how that has a billion views, I have no idea. Anyway, use the scatter plot to estimate the number of views for the most popular video in this 10-year span. You can do that. Estimate when the 4th most popular video was released. 1, 2, 3, 4. I could see the 4th most popular one. I see the most popular one way up top. And I count 4 down. Use the scatter plot to estimate. I'm going back to that first one. And it says estimate the number of views for the most popular video in this 10-year span. I'll let you guys knock that out. And question 3, wow, pretty short assignment. Number 3, a recipe for bread. Give baby some bread. Recipe for bread calls for 1 teaspoon of yeast for every 2 cups of flour. Name the 2 quantities in this situation that are in a functional relationship. Well, that's straight up right there. Write an equation that represents the function. 1 teaspoon of yeast for every 2 cups of flour. And draw the graph of the function. Label at least 2 input-output pairs. So there's a graph. Call it what you want. You could put teaspoon here. You could put flour here. Or you could put flour on the bottom if you wanted and put teaspoons. It doesn't matter. It all depends on what your equation is going to represent. But I'll let you figure it out from there. Label at least 2 points, though. And it should be pretty straightforward. Don't make this any more complicated than it is, because you don't need to use big numbers here. If 1 teaspoon of 2 cups of flour, don't worry about what 10 or 100. What is 2 teaspoons? What is 3 teaspoons? So I'll let you guys finish the rest from here. And we'll call it good. Good luck with everything. Email me if you got any questions or concerns. I'll be able to respond to email throughout the next several days. And tomorrow we're going to finish up Unit 6. I know it's abbreviated, but technically then on Monday we'll get rock and rolling with Unit 7. So keep up the good work. Keep it real. Keep it good. Peace.